We're going to use our pictorial to review some key concepts of our unit. You may pause the video at any time if you need more time to write your answers down. So let's review what a convection current is. You can write this at the bottom. So a convection current is the transfer of heat energy through a fluid due to gravity. So we can just write the transfer of heat through a fluid due to gravity. So, why does the warm air rise? Well, that's because warm air is less dense than cold air. So we're going to go ahead and write that up here. Warm air is less dense. Therefore, it does what? It rises. So we can draw arrows showing it going up. Cold air is more dense, causing it to sink to the surface. Cold air is more dense, causing it to do what? That's right, causing it to sink. The rising air leaves room for more air to move in from other locations. As the air rises, it cools and spreads out along the top of our troposphere. Cooler air is more dense and sinks, creating the area of high pressure. The air moves from the area of high pressure to the low pressure, and we call this wind. So we can go ahead and draw some wind at the top. Now our wind ultimately comes from the energy of the sun. So if you want to draw a sun up here, that might help you. Now we're going to talk about sea breeze and land breeze. Our sea breeze is caused by air currents moving from the water to the land, and this happens during the day. So we're going to write sea breeze during the day. Air currents move from water to land. So our air is coming from our water and moving over our land. Now what happens is our water is typically colder in some areas, therefore it's bringing that cold temperature off of the water onto the land, making our air over the land a bit cooler. We see this near the coastal regions, and that's why they typically have cooler summers and warmer winters than, say, we do in Texas. They're getting this nice breeze off of the cold water. Then we have our land breeze, and our land breeze happens at night. So during the night, air currents move from land to water. And this is caused by uneven heating of land and the water. Our land heats and cools faster than water. This happens at night. Our warmer air over the ocean rises, and our cooler air over the land sinks. The wind blows from the high pressure, from over here, our land, to the low pressure on our water, our sea. Now, our coastal areas are going to receive more rain and more thunderstorms than our inland areas. And this is because the evaporation is coming off of the water, filling our clouds with more water vapor. So our areas around our oceans that are bordered by all sides are going to see more thunderstorms than we are, say, in Dallas or Chicago. We can write thunderstorms. Now, say we were to have a mountain over here. So we can draw a little mountain. Where would we expect to see more vegetation, more trees and more grass? So I want you to look at this, and I want you to think for a second, where are we going to see more vegetation, more trees? Down here by the water, up at the top, or if we were to continue our mountain on the other side. So take a second and think about that. If you guessed near the bottom of the mountain closest to the water, you're correct. We're going to see more vegetation closer here to our water than we are, say, on top or on the other side.